To class, this is Mr. Ryan again. This is now Wednesday, 4:15, and now we're going to do something that's been around for 400 years. This Pascal was in the 1600s, and he made this triangle here to help solve in the kind of problems like x plus y to the n. So this is a way of constructing this table. If you'll just notice how it works, on the right side where we have the numbers, at the very top is 1, to the left and right below that is 1 and 1. Now how to make the third row where n equals 2 is if you look above the 2 to the left and right is a 1. And so that's what you added to get the 2. So there's always a 1 on the left and on the right ends, and then you use the 2 to the left and to the right above to add. So that's like x plus y squared is 1x squared plus 2xy plus y squared, 1, 2, 1. And now 1, 3, 3, 1 is for n equals 3, which is 1 on the ends, and then above the first 3 is the 1 and the 2, which we add, and then above the second 3 is the 2 and the 1, which we added to get the 3. And so that's for x plus y to the third. That would be the coefficients for that. Now for the next row down, 1, 4, 6, 4, 1, we'd have 1 on the ends. Above the 4 is the 1 and the 3. That's how we got it. Above the 3, 6 is the 3 plus 3, and above the 4 is the 3 plus 1. That's for x plus y to the fourth, giving coefficients. Now for n equals 5, which will be as far as we go, we have 1, 5, 10, 10, 5, 1, and that works the same way. And notice over to the left, these are the combination. So the top is 0C0, the first row is 1C1, 1C1, and these are the numbers that generate those numbers to the right in the triangle. So you can see that we're just working through the combinations. So for instance, row 3 is 3C0, which is 1, 3C1, which is 3, 3C2, which is 3, and 3C3, which is 1, 1, 3, 3, 1. And each row works that way. So now in general, this allows us to know how to do this binomial theorem for any positive n. So in general, for x plus y to the n power, we have nc0, x to the n, plus nc1, x to the n minus 1y, plus nc2, notice the pattern, x to the n minus 2y squared, plus dot 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 ncn, y to the n. Now NC0 and NCN are both 1. Those are the coefficients at the front and the end. And depending on the n, we know we can generate the table from that triangle. So example, let's expand x minus y to the fourth power using n equals 4 from Pascal triangle, and I'll circle the ones that are used, the 1, 4, 6, 4, 1. So we have 4C0, x to the fourth, negative y to the 0, which is just 1, x to the fourth, that should be x to the fourth, okay? So then 4C1 is 4C1, x to the third, negative y to the 1 power. 4C1 is 4, x to the third times minus y, so that's minus 4x third y. That's below, on the bottom line. Then the third term is 4C2, which is 6, x squared minus y squared. So that's 6x squared y squared, the third term. And then the fourth term is C3, 4C3, x1 negative y to the third, which is 4x negative y to the third, or negative 4xy to the third below. And the last term is 4C4 negative y to the fourth, or just 1y to the fourth. Now remember, that's a mistake there, so that first one should be 1x to the fourth, or just x to the fourth. Now here, for the next example, we're expanding a plus 2b to the fifth, so we use the n equals 5 line. Notice I have circled the 1, 5, 10, 10, 5, 1 on the line below the first line. So here we go, 5c0, a to the fifth, 2b to the 0, which is just 1 times a to the fifth, plus 5c1, a to the fourth, 2b to the 1, which is plus 5a to the fourth, 2b, or below 10a to the fourth b. The third term is 5c2, a to the third, 2b quantity squared, or plus 10 a to the third 4b squared. So that all comes to plus 40 a to the third b squared on the bottom line. Then the fourth term is 10 a squared 8b to the third from 2b quantity cubed. And that's plus 80 a squared b to the third. The next term is 5 a to the 1 times 16 b to the fourth from 2b quantity b to the fourth, which gives me 5 times 16 or 80b to the fourth. And then the last is 5c5, and that's times 1, because it's x to the 0, and 2b to the fifth, which is 32b to the fifth. So the final answer there is a to the fifth plus 10a fourth b plus 40 a to the third b squared plus 80 a squared b third plus 80 ab fourth plus 32b to the fifth. And I hope you can see how that worked out. Just go over it one more time if you can. Now in example 3, we're asked to do something easier. Find the third term in the expansion a plus b to the fifth. Well, remember 5c0 would be the first, 5c1 would be the next, and 5c2 would be the third. So notice how we pick 5c2 for our coefficient, which is 10, 1, 5, 10, 10, 5, 1. And we have a to the 5 minus 2, or a to the third, and b squared. So 10 a to the third b squared. Now to use this in binomial as we do in statistics, we say that probability of success we call p to shorten it down, and probability of failure is 1 minus p or q, so that p plus q add to 1. So now we can do the binomial probability, which is done a lot, as I said, in statistics, like it's Chattanooga State when you do that in 12th grade if you take statistics, which is ncx for a particular term, p to the x, q to the n minus x. Now for example 4, we'll find just one term. Find the probability of getting exactly 4 heads on 7 flips of a fair coin. Now this is pretty easy because the probability of success is 1/2 for heads and q is failure, so that's 1/2, so that p plus q equals 1 always. And my formula, p of x is equal to ncx, p to the x power, q to the n minus x, and that's 7c4, 1/2 to the fourth, 1/3, 1/2 to the third. So the 1/2 is easy, it's just 1/2 to the seventh, but let's do 7c4. Now remembering from last week when we did combinations, it's 7 factorial, the first number, over 7 minus 4, the 3 factorial, divided by 4 factorial, the second number. So this on top becomes 7 times 6 times 5 times 4 factorial, and the 4 factorial on bottom cancels, and then divided by the 3 factorial, or 3 times 2 times 1, which turns out to be multiplied on top. 210 over 6 is 35, and to get the 1/2 to the 7th, we do the 2 power 7 on the calculator is 128. So now 35 times 1/2 to the 7th is 35 over the 128, because 1/2 to the 7th is 1 over 28. And 35 over 128 comes out to about 0.27, so we'll call that 27%. Now example 5, a student randomly guesses on each question of a quiz consisting of 5 multiple choice questions, each having 4 choices with only one correct answer. So the probability of a correct guess would be 1 out of 4, or 0.25 for p, and the probability of a wrong guess would be 3 out of 4, or 0.75 for q, so that p plus q equals 1. Now we're going to look at all the parts of p plus q to the fifth and see that they all add up to 1. That's what we're doing this for. So doing the first term is 5c5 p to the fifth. Second term is 5c4 p to the fourth q to the 1. Third term is 5c3 p to the third q squared plus 5c2 p squared q to the third plus 5c1 p to the 1 q to the fourth plus 5c0 q to the fifth. And so now, working out what those are, p to the fifth, 5c5 is 1, times 0.25 to the fifth, when you get that out and you round it to 4 places, is 0.0010 below. Now 5c4 is 5, times p to the fourth 0.25 to the fourth times 0.75q, and that all multiplies out to 0.0146. And then the third term plus 5c3 10 p to the third q squared is 10.25 power 3 times 0.75 power 2, which comes out to 0.0879. Then the fourth term is 10.25 squared times 0.75 to the third is 0.2637 to 4 places. The fifth term is 5 times 0.25 times 0.75 to the fourth, which is 0.3955. And the last term is 1.75 to the fifth, or 0.2373. And those are all rounded to 4 places, and when you add them up, you get exactly 1. Now, let's find out which one is most likely. Well, we can see above the biggest one is 0.3955, and so that's the most likely, which turned out to be 5c1 p to the 1q to the fourth, or 5 times 0.25 times 0.75 to the fourth, or 0.3955. And it is because the largest term in part A, it is, we can see from above that it is. Now, probability C, what's the chance of missing more than 1/2 of the questions? That would be when the number of wrong answers would be 3 or 4 or 5. So we could say 5c2 p squared q to the 3, which we know from above is 0.2637, plus 5c1 p q to the 4, which is 0.3955, plus 5c0 q to the fifth, 0.2373, which is 0.8965, and that comes out to roughly 0.9 or 90% of missing more than half the questions. Think about that on guessing on a test for multiple choice, like the SAT. Okay, now here's the homework starting on page 580, and we're going to use n equals 5 in Pascal's triangle to evaluate x minus y to the fifth. So remember, the Pascal's triangle is 1, 5, 10, 10, 5, 1, which we've already used, and that's 5c5 x to the fifth negative y to the 0, plus 5c4 x to the fourth negative y to the 1, plus 5c3 x to the third negative y squared, plus 5c2 x to the 2 negative y to the third, plus 5c1 x to the 1 negative y to the fourth, plus directly below 5c0 negative y to the fifth. So that comes out to 1 times x to the fifth minus 5, the second term, x to the fourth y. The negative y brings in front of the 5 is negative. The 10 for 5c3, x to the third y squared, negative y squared is positive. For the fourth term, 10, x to the third, negative y to the third comes out as a negative in front of 10, x squared y third. The fifth term is 5, x to the 1, negative y to the fourth, which is positive, so plus 5xy to the fourth minus y to the fifth. So that's 2. Now in problem 4, we won't have many more of these, so just hang on. We're going to use the Pascal triangle n equals 4 to evaluate 2a plus b equals 4. Now remember, the first thing that we put the power to is 2a. The second thing that we put the power to is b. So remember, it's 1, 4, 6, 4, 1, which I have circled on the line below. So it's 1 and then 2a to the fourth power, which is 16a fourth, plus 4c3, 4, 2a parentheses third power, which is 8a to the third. So that multiplies to 32a to the third b, plus 4c2, 2a squared b squared, which is 6. 4c2 is 6. 4a squared b squared, or below, is plus 24a squared b squared. And then 4c1 is 4 times 2ab to the third, or 8 plus 8ab to the third. And then the last term is 4c4, or 1b to the fourth. And that finishes problem 4. Okay, just one more like this, and then we'll get easier. So x minus 5y to the fifth. And remember, the Pascal's triangle for n equals 5 is 1, 5, 10, 10, 5, 1, which is mostly underlined below. Okay? So here we have 5c5, which is 1, x to the 5th, and that's the first term, plus 5c4, which is 5, x to the 4th, minus 5y, makes it negative 25, x to the 4th, y, which is below. The third term, 5c3, which is 10, which is above the top line, x to the third, negative 5y parentheses squared is 25y squared. So that gives me for the third term below on the bottom, circled or squared, plus 250 x to the third y squared. Now here we start getting big. And then on 5c2, it's 10 x squared negative 5 to the third, which is 5 power 3 or 125 y to the 3 with a negative. So that's negative 1250 x squared y third plus 5c1 x1 negative 5y to the 4th. So you'll have to take 5 power 4 on your calculator. And there you get plus 5x times 625y to the 4th, which gives us plus 3125x y to the 4th. And then plus 1 times negative 5y to the 5th, which turns out to be the same as the number before, but with a minus 3125y to the 5th. Now that's the long one, but that's the last of those long ones for now. So for problem 8, find the probability of 8 successes in 9 trials with p equals 3/4 or 0.75, leaving q equals 1/4 or 0.25. So we have 9c8, 0.75 to the 8, 0.25 to the 1. Now 9c8 is 9 times 8 factorial over 1 factorial times 8 factorial, and the 8 factorials cancel to give you 9. And the rest of it is 9 times 0.75 power 8 times 0.25, which to 2 places rounds to 0.23. Now on problem 10, we have 9 successes in 12 trials with p equals 0.95, and the probability of success or failure, that was the probability of success, 0.95. Probability of failure equals 0.05. Now 12c9 we'll have to figure out 0.95 to the 9, 0.05 to the 3. So 12c9 is 12 times 11 times 10 times 9 factorial over 3 factorial, 3 times 2 times 1 times 9 factorial, which is 1320 over 6 or 220. So this comes out to 220 times 0.95 power 9 times 0.05 power 3 rounds off to 0.02 to 2 places. Now on 12, we're asked to determine whether the trial is given as binomial or not. So choosing a blue marble from a bag containing 4 blue, 6 white, and 5 green on 3 successive draws when the marble is replaced after each trial. Well, we know that there's a fixed number of marbles, 6 plus 5 plus 3 or 14, so it has to be, n has to be fixed for it to be binomial, and it is. And the probability of success is blue, 4 over 15, and the probability of failure is not blue, or 11 over 15. So those conditions are met, the probability of success and failure. And everything, and because the trials are replaced, the marble is replaced after each draw, that makes it independent. The trials are independent, so yes, it is binomial. Now on problem 14, we're given another case to see if it works. Now 20% of the boxes of popcorn sold at a ball game contain a token for a free soft drink. If the Bauer family buys 6 bags of popcorn, what is the probability they will get 4 free tokens for free soft drinks? Well, n is 6, so that's fixed. Probability of success is 0.2 or 20%. Probability of not picking the token is then 0.8 or 80%. And the trials are independent, and n is fixed, and probability of success and failure are there. There's only 2 cases, and so yes, it is binomial. Now, on 16, we're asked to find the 5th term of x minus 2y to the 8th. So we can just count out 8c8 is the first, 8c7 is the second, HC6 is the third, HC5 is the fourth, HC4 is the fifth. So HC4 comes out to 8 factorial over 4 factorial times 4 factorial, or 8 times 7 times 6 times 5 times 4 factorial over 4 times 3 times 2 times 1 times 4 factorial, or multiplying the top number 1680 over 24, or 70. So now coming back, we have 70 x to the fourth, negative 2y in parentheses to the fourth, or 16y to the fourth. So 70 times 16 is 1120, x to the fourth, y to the fourth. Now on 18, we want the last term of x squared minus y fifth to the ninth. So this is easy. This is 9c0 negative y to the fifth to the ninth power, which is just 1 times negative y to the multiplying exponent's 45th power. So that was easy. Now 20, x minus 1 to the 8th, find the term with y seventh. So this is 8c1, x to the 1, negative y to the 7th, or 8c1 is just 8, 8x, negative y to the 7, or putting the negative in front, negative 8x, y to the 7th. Now what is the probability on 22 of getting exactly 5 heads on 12 tosses? Well, that would be 12c5, 0.5 to the 5th times 0.5 to the 7th, because heads or tails is both 0.5. So this would be 12c5 evaluates as 12 factorial over 12 minus 5, or 7 factorial divided by 5 factorial. So the 7 factorials cancel, and it's 12 times 11 times 10 times 9 times 8 over 5 times 4 times 3 times 2 times 1, or 95,040 over 120, or 792. So the final answer comes out to 792 times 0.5 power 12, which rounds to 2 places to 0.19, or 19%. And now Kevin Durant, if you follow basketball, you would know him, made 86% of his free throws. What is the probability that he would make 9 of his next 10 free throws with a probability of success 0.86, of failure 0.14, because it's 1 minus 0.86. So that would be 10c9, which would be 10 factorial over 1 factorial, 9 factorial. The 9 factorials cancel, leaving just 10. So this would be 10 times 0.86 power 9 times 0.14, which would round to 2 places to 0.36, or 36%. And I know this had a lot of details in it, so just hang with me. God bless you all, and hope you'll be able to get a Facebook Live tonight on Wednesday. See you tomorrow.